Structural analysis is basically the process of identifying the forces and various actions that will be acting on the structure. So based on these forces, then we decide on what is the column size or beam size or whatever is the structure size. So basically, structural analysis is that process where you identify what are the actions on the building or on the structure, any structure, and then deciding how to go forward with the design. And we'll go through, there are various ways how we do the analysis. Of course, you would know the manual methods to do the analysis, which you will study through your graduation and post graduation. And there are also various softwares like etabs or SAP or StatPro, which are used to do these analysis as well. So I think that answers the question. The next one.
So the next question is, what are the biggest challenges faced by engineers or architects in the construction of high-rise buildings?
Okay, that's again a good question. So firstly, I'll split it into two parts. The question is on construction of high-rise buildings, but I'll also discuss on the design first, and then the construction of high-rise buildings. Now, the basic principles of design of a high-rise buildings is very similar to any other building. You are G+5 or G+10 or G+100. The design principles are same, but what is different in a high-rise building is the extent of forces that's acting on the elements. So your basic loads such as dead loads and your live loads will be more because you have more number of floors. So your element sizes are going to be more. And how you accommodate these bigger structural elements within your plan, and how you still provide all the required usable spaces to the client, that is the first biggest challenge. So as structural engineers, our first intent will be to provide the minimum or the most efficient size of the structural members like columns or beams or slabs, so that it is easier for the architects to provide more usable space to the client. So unless there is not much usable space, you cannot get much profit out of the project. So that is the first step, definitely, and or the first challenge. Then we also have other disciplines involved in the design, like you have MEP, which is mechanical, electrical, and plumbing. Now, how you provide all the duct work, all the air conditioning requirements for the full tower, how you get all the electrical load that is required to provide electricity to the full tower. All these things are also challenges in the design of a high-rise building. Now, in terms of structures, again, in addition to the dead load and live load, you also have the wind loads acting on the towers. So the higher you go, the more is the wind load that will be acting on your building. So obviously, you'll have to find ways how to mitigate these wind loads. I'll answer that in a short while as well. But that is a big challenge. The smaller buildings, wind loads are not very critical, but the higher you go, the wind loads will become more and more critical. So that is another challenge as a structural engineer that we will be facing. There are ways how you mitigate this challenge as well, which I will also go through in some time in some of the other questions. So that is in terms of design. And you also have lifts to be provided, how you access the higher floors, and you need faster lifts to go higher. Obviously, you don't want people waiting in the lobby area for lifts to take you to their floors. So all these things also become very big challenge in terms of high-rise buildings. Now, in terms of construction itself, firstly, it is how you, just in terms of structural engineering or in terms of civil engineering, the first question is how you transport this concrete to higher floors. Now, it is not easy to pump concrete to a height. You need pumps with more power and pumps with more efficiency to pump these concrete to the higher floors. So that is the first challenge, how you construct these higher floors itself in terms of pumping concrete. And the second one is how you provide the cranes. You need taller cranes. You need people who can operate these cranes at a higher level, and you also need space to put these cranes around the building. Now, if you see, many of the tall buildings will have a very small footprint, so you need to find place within the tower or around the tower to put these cranes. So this is also another challenge. So the other thing is the maintenance of the tower itself. So I said about the MEP, how you provide the equipments for the MEP at a higher floor, etc. Now, how do you maintain these? These may need regular maintenance after 5 years or 10 years. So how you access these, and if you have to replace some of these components or equipments, how you provide access to replace these. So all these things are going to provide challenges in terms of construction of high-rise buildings. And also in terms of reducing the load, we try to go for lighter materials. You need concrete with higher strength. Generally, for small buildings, you will use like 40 or 50 or even 30 Newton per mm square. But for higher buildings, it will be 80 or 90. So you need the technology to prepare this sort of high strength concrete, and to deal with all these issues on site in terms of workability, etc. So all these things are challenges in terms of construction of high-rise buildings.
So we have a series of questions here.
Mhm.
So high-rise buildings are surely structural marvels. What does it take to design them? They're asking about the foundations, its effects on the environment, and the external factor consideration taken while design and construction.
Okay, that's a nice statement. High-rise buildings are surely structural marvels. Nice to nice to hear that being a structural engineer. So, what it takes to design them, this is basically what I answered in the previous question. So, in terms of the principles of design, it is not much different from any other building. It is only in terms of the magnitude of forces, the magnitude of the structural element sizes. The only additional factor is the heavier wind loads that are going to act on your high-rise building. So there is a way how you design the elements to take this wind force, which is what you generally do in a shorter building. But for a tall building at the concept level stage, the geometry of the building itself is modified to accommodate or to reduce the wind load as much as possible. So if you see the shapes of some of these high-rise buildings, for example, if you see Burj Khalifa, you can see that the base of the building is much wider than the top of the building. So the building sort of tapers as you go up. And one of the reasons why they do this is to reduce the wind load, because the wind force is higher at the top. So as you reduce the area of the building or surface area of the structure, the wind load acting on this building is going to reduce as well. So that is one way how they reduce the wind load. There are also other ways where they provide open floors at certain levels to allow the wind to pass through. So that is also a way to reduce the wind load. Or you can see some structures which have huge openings at the top of the building. So all these are ways how you mitigate the effect of the wind load, and that is the main concern or main challenge, and to be considered for design of a tall building or a high-rise building specifically. So that is one point. And then the foundations, and it's okay, the foundations, it's more of what is the soil in that location, what is your geotechnical capacity in that location. But definitely you will have a feasibility study before you go into design of such a big project. So there is always an initial stage of design where some design consultant will come and study the soil, what are the layers of soil, how much load it can take, and then we decide on what will be the foundation capacity of this building. And based on that, we decide on what will be the number of floors. So generally, the foundation will be pile foundation for all the tall buildings. In some cases, you can also go for a raft foundation, but this will be where you find proper rock material at a very high level in the ground. So it depends on the soil condition, but most of the cases it will be piled foundation for tall buildings. And its effect on the environment, well, that's a tricky question, because obviously any construction activity is going to have some effect on the environment. But how we mitigate this effect is through sustainability of the building itself. So if you see the tall buildings, many of these buildings will have sustainability ratings, which is basically how they reduce the usage of power in the building, or how they generate powers within the building. Now, if you see, there are a couple of buildings, I think, around the world which have windmills on the building itself. There's one in Bahrain if you want to check out. So, this they say will provide, or it will generate electricity, because it uses the wind forces at such heights of the building. So that energy is used to generate or to use the electricity in the building itself. This is a way how you pay back for all the effects on the environment. So it's basically, you definitely have an effect when you construct a building, but how you solve that or how you negate that effect throughout the life of the building is done through sustainability. And this in itself is a branch of study, or it in itself is a design consultancy field who suggests certain measures to solve or to negate the impact on the environment itself. So that is one factor. The next question, I am not clear what it says. The external factor consideration taken while, well, in terms of loads, it is only the wind and seismic loads that's acting on the building in terms of external factors. In terms of construction, definitely we will check all the logistics, the location around the construction site, how we can access the site, if it is possible to construct that sort of a building in that location, if we have all the available materials locally to use for the construction, and all these things, etc. Next one.
So how well can your project management impact on these structures? Qualification and experience required for becoming a designer of high-rise buildings.
Okay, project management. That's again a good question. Definitely, there are a lot of consultants involved in the design and construction of a high-rise building. Like you have an architect, you have a structural engineer, you have a mechanical engineer, electrical engineer, and so on and so forth. There's facade, lift. So there is definitely requirement of a project management person who drives this project. So what they do is generally they plan the project, construction of the project, and design of the project. They fix the various stages that are required throughout the construction of this project. They cross check that all the consultants meet the required milestones, and then they also cross check all the cost requirements of the project. So, definitely, project management will be required to keep the budget of the project within control, and also to make sure that the project is delivered on time. Now, delivery on time is very critical because at the end of the day, the client wants the project to be built. Then only he can either sell it, or he can lease it, or he can rent it, or whatever. So it is very critical that the project is constructed on time. Any delay in project is loss for the client or for the contractor, depending on the contracts. So yes, project management will have a huge role to play, because the construction of a tall tower itself will be 3 or 4 years. So this is a long time, and then to keep track of things, definitely a project management team is involved in the construction site and in the design phase also. In terms of qualification required for becoming, okay, it's basically it's a structural engineer who does the structural design of high-rise buildings. So if you are a bachelor's of engineer in civil, that is good enough to start a career in design of buildings. And if you have a master's, that is an added advantage, definitely. A master's in structural engineering. Next one.
So next is related to softwares. So which is the easiest software for high-rise buildings? And could you take us through SAT Pro or SAP 2000?
See, there is no easy software or easiest software for any project or any discipline. I can say it all depends on the user, and different softwares are easy to use for different people. I may find some software which is easy, and there will be some other engineers who prefer another software. Now, I can advise in terms of which is the most used software for high-rise buildings, and that is definitely ETABS is used mostly for high-rise buildings. And the reason it is built for three-dimensional design of high-rise buildings. The way ETABS is designed is for tall buildings itself. So it is very good in assessing the forces on the building, in analyzing the forces, and it also gives you the required output for the design of the high-rise buildings. So ETABS is a good software. And among StatPro and SAP, StatPro is also good. Actually, StatPro is more used in India. It is also good for high-rise buildings, but I think StatPro is more suitable for steel structures than RC structures. So ETABS is more of a RC structure software. It does steel also, but then it is more efficient in RC design, I can say, compared to StatPro. So StatPro is more of a steel design software. It can also do RC, and it is used for RC design also. So in on a comparative basis, ETABS is good for RC, STAT is good for steel. SAP is very similar to ETABS because is basically done by the same company who designed ETABS also. But SAP is more for an advanced level of engineering, I can say, because it is suitable for irregular shapes. So more than used for buildings, it will be used for buildings with an irregular shape, like a thin shell structure or like a curved sort of structures, because the modeling in SAP is not as easy as modeling in ETABS. ETABS defines your floor levels and other things, so it's easier to model a tall building in ETABS compared to SAP. SAP is also good, but not as good as ETABS. Now, again, this is my personal opinion. There will be other engineers who prefer to use a different software than ETABS, but the most used software around the world is ETABS for tall buildings. Next one.
How to design a building manually without using design softwares?
How to design a building manually? I'm just thinking how to answer this question. Basically, your graduation and post graduation teaches you design of different elements of a building. You will have courses which gives you design of RC structures, design of steel structures, where they give you examples of design of a column. Similarly, there are courses for analysis of RC structures or steel structures. Now, designing a building is basically putting all that you learned together. So first, you try to understand how you calculate the loads on the building using various codes, so that you can do manually because all the formula are there in the code or the input parameters are there in the code. Then you do analysis using various methods. There are different methods to do analysis. Some of them are approximate methods which can be used. Then you design using the codes or using the examples in books or whatever it is that you use in your everyday design. So that is the simplest way I can say. But you'll the only thing in designing manually is you'll have to make a lot of assumptions. You'll not, if it's a simple two-story building, let's say, with a three frames or four frames in each direction, it's easy to design. But once the building becomes a tall building, like you have 60 floors or 70 floors, then the process of iteration is too much. So it is difficult to do an efficient design manually. That is the reason we use softwares, because it iterates faster and it's easier for you to economize or efficient provide an efficient element size, because you can run more number of trials using a software, whereas when you do it manually it takes more time. But yes, it's possible to design manually, and we also do manual checks always. We have quick thumb rule checks which we do to cross verify the outputs that we get from the model. It is very critical step to do. So it is essential that you know how to design manually, but you only do approximate calculations to cross check it against the values you get from the model. And as long as your values from the model are plus or minus 5 to 10 percentage from your manual calculations, then your model is good to go. If you find some sort of difference, then you again cross check both, and either one of these will have to be corrected. I hope I answered that question, if I understood it correctly.
I'm sure you did, sir. So, what types of new problems are facing in constructions of high-rise buildings in the present time? On which area design engineers are focusing this time for improvement in construction? In India, what type of problems are faced in the construction of high-rise buildings? And in which area of India is it difficult to construct high-rise buildings?
Okay, I'll take this question part by part. That's like four questions in one.
Sure.
But again, all of these are good questions. So, what types of new problems? I wouldn't say these are problems. It's always challenges that you face. There are two parts of this one. I don't know which one the person asking the question is referring to, because when he says present time, the whole time that we are going through is difficult. So I'll take it two parts. One is the technical problems that we face. It's again not problems, it's challenges. I think the main thing that we focus on high-rise buildings is to make it as efficient as possible in terms of design. Like I told you earlier, the client wants usable space. So as structural engineers, it is essential for us to provide a plan layout where there is more usable space. So our intention is to make the the structural elements within a tower or within a building as efficient as possible within all the allowable code requirements. So one way of doing this, for example, is to provide composite structures. Now you have RC concrete columns, which may require a certain size, but then we use composite columns, like we put a steel structure or a steel section within the RC column, which reduces the required size. So basically, you are enhancing the strength of the column by introducing a steel section into it. So that is one way of minimizing or making your columns as efficient as possible, which means you give more space to the architect to work with. So that is one type of challenge that you face. And like I said earlier, use of high strength concrete. So there is a lot of studies going on how you increase the strength of the concrete, because the higher strength of concrete, again, the lesser column sizes that you will have. So that is one type of problems you are facing. In terms of construction, again, your construction technology, how can you make it faster? How can you make processes repetitive? Because construction time is huge for high-rise building. It can go from 3 years. Some buildings even go 7 years, 8 years, or 10 years. Now, this is all cost for the client. So at the end of the day, we have to try to reduce the cost for the client. So in order to do that, we try to see where we can save time in the construction period. So there are places where they use robots now or artificial intelligence now to try to make these repetitive processes as fast as possible. So that is one area which the industry is continuously looking upon. The other one is your sustainability, like I said. How do you construct a building with minimum impact on the environment? Because now you know all these climate change issues that are going on. So you need to reduce your carbon footprint or your carbon output from construction. In fact, construction is one of the leading contributors to all this climate change. So it is the industry is also studying on how we can minimize the carbon output or carbon footprint by constructing more efficiently. And also there, this is just related to civil engineering. There's also technological studies going on in lift mechanism, how to make the lifts faster, how to transport people faster between different floors, and how to provide better air conditioning in terms of mechanical engineering, and how to uh, minimize the electrical load on a building in terms of electrical energy. So all these are challenges. I won't say these are problems, and these are not new problems. Also, these are challenges that you face every time or during any construction period, and the industry continuously tries to find new ways of becoming efficient in each of these. That is the technical side. Like I said, during current time, because of all this that's going on around with COVID and other things, you definitely have challenges in how you get people to work on site, because construction is not a field that you can do remotely. You will have to go in person. You will have to coordinate on site. So there are ways they do that on site. They make sure that it's safe for everyone to be on site and work. So that is one way, one thing also in terms of challenges in present time. And the next question, on which area design engineers are focusing? In terms of design, like I said earlier, it is how to minimize your vertical element sizes. So one way is you address it in the design of the element, like you provide composite columns to reduce the size, or you provide shear walls or more shear walls or less shear walls. That is one way of doing it. Also, each day we have new softwares coming in, and we have more faster softwares which helps us to run faster analysis, and the faster you analyze, the more iterations you can do. And as engineers, we need to run more iterations to make sure if something works or doesn't work. You run more options, there is more chances of making your building design more efficient. So with faster programs, with faster softwares, you are able to run more iterations and make your design as efficient as possible. So that is in terms of design. In terms of analysis, there is also a lot of studies going on in terms of the wind load study on tall buildings. So are we assuming the correct loads? Is there any way we can reduce the loads that are assumed? Are we are we designing too conservatively? So these are also a lot of studies that are focusing on how to improve all these things in terms of design engineers. Uh, then in India, I think the problems are pretty much across the world. There's no specific problem in India compared to the other parts of the world. Maybe one additional challenge I would say is the technology is not in India is not as developed as some of the other countries like US or maybe UK or even the Middle East. The technology in India is coming up, but it is still not as advanced. So, in terms of high strength materials, it is still possible to achieve in India, but it may be a bit costly. So, the clients become a bit conscious, and also in India, it is more the clients are more economy oriented, so it is very critical to provide uh, maximum usable space with minimal structures. So this is again, it's a challenge. It's not. I wouldn't say any of these as problems. All these are sort of challenges that we face as engineers. And in which area of India, uh, there is no area we can really pinpoint. It depends on the geography of the area. It depends on the soil conditions in the area. In the same city, you will find places where you can construct certain height of building, whereas in other parts of the same city you cannot do that. So it depends on the soil conditions also. It depends on the local authority requirements, because in some areas you cannot go beyond a certain height. So that is there. And also it depends on the seismic zone of the place also. If it's a high seismic zone, obviously it is costlier to construct a high rise building compared to a low seismic zone. So all these factors will be there. uh, there is not no possibility of saying this area is not good or this area is not better. Yeah, next one.
So I think you already talked about this. Buildings like Burj Khalifa, how have they carried out the foundation works in that stand?
Okay, this when we say, yeah, we know Dubai is sort of a desert, and then the sand here is it's very sandy in nature. It's very fine in nature, but this is the topsoil only. So when you're constructing a building like Burj Khalifa, with any high-rise building, you will require a lot of car parking spaces, because if it is a residential building or an office building, you will need a lot of car parking spaces. And the way they address this is they always go basements. So any high-rise building, most of the high-rise buildings, I will say, will have 3 or 4 basements at least. And the moment you go into the basement, you are already crossing the top soil on the ground. So this sand that is questioned here is mostly the top soil, top layer of the soil. Even in a place like Dubai, as you go deeper, you will find better soil. You will find rocks after a certain depth. So what they do for Burj Khalifa or any building in the Middle East, mostly they will go for basements, obviously, because it's required, and then they go for piling. And these piles were maybe anywhere between 30 to 60 meter or even longer in some cases, and they will reach the rock strata below. So that is how they provide the foundation. It will not be a raft foundation, it will be a raft on pile foundation, and these piles will go all the way down to the rock strata. I think that answers the question.
What can be the appropriate alternative method for reducing wind loads in high-rise building construction instead of
Hmm.
reducing the floor area with the height? Apart from the foundation, which part of the structure withholds maximum wind load in an apartment?
Okay, first part of the question. This is one of my uh, favorite aspects of designing high-rise buildings. So, like I did explain this briefly before, but I'll just explain again here for somebody who was joined late. See, for a high-rise building, the wind loads are the most critical of all the loads. The higher you go, more than the seismic load, the wind load plays a bigger part. There is two reasons for it. One is the strength design of the building itself, which is basically your the load carrying capacity. The second one is serviceability requirements. Serviceability requirements is basically you have a building. It's like a cantilever structure with your fixed base on the ground. So when the wind blows onto the building, it is going to deflect. It will it will not just deflect, it will try to come back to its own position. So it is more like like a pendulum which is swinging when there's wind load acting on it. And when, as you know, when a building is moving or swinging, any person who's staying on the top of the building, at the top floors of the building, he may feel a small movement. And this will not be like it's really moving, but he will feel sort of giddiness, or he will feel some sort of uncomfort feeling when he is staying there and the building is moving. So the one of the main aspects of tall building design is to control this deflection. It is a very critical part of design, and it is one of the most checked things in any tall building design. So, how we control this deflection is by increasing the stiffness of the structural elements. So, that is also part of the design. Now, one way is you provide as much stiffness as required for the wind load acting on the building. The other way is you try to reduce the wind loads acting on the building. So that is the question here. So one way of reducing it is, like I said, for Burj Khalifa, your your base of the building is wider and it gets narrower as you go up. So you're basically reducing the surface area of the building, which means the wind load acting on the building is reduced. The second method used will be to provide certain floors as open floors, which means there will be no glazing around it. So you'll have a open floor, let's say on 20th story or 40th story of the building. So basically, you're allowing the wind at that level to pass through the building, and they use this open floor as sky gardens or some sort of recreational activities or restaurants or whatever. So the architects come up with various ways to use this open space. You can see examples of various buildings with sky gardens at higher levels. So one reason for providing this is to reduce the wind load on the building. There is another method is to provide huge openings at the top of the building. If you see, there's a tower in Saudi Arabia. I don't remember the name, but it's in Riyadh. They have a huge opening at the top of the building. This is again to allow the wind load to pass through the building. Once you allow this wind load to pass through, there is no impact on your building. So that is another way of reducing the wind loads on the building. The fourth option is to slightly change your geometry. Like if we see Taipei towers, Taipei 101 in Taiwan, I think. So they have corners which are sort of stepped corners. If you see the plan, you will understand. So this is again to provide corners which are rounded or which are stepped. This also helps in reducing the wind load acting on the building. So these are things that we do at a concept level with the architects, with the wind tunnel specialist. We sit down with them as structural engineers. We do certain studies and we tell, okay, this wind load is too much. How do we try to reduce it? These are the various options that I said now. And then we decide through coordination and we come up with ways to reduce this wind load. So I think that answers the question. One second, there's another part to the question. Apart from the foundation, which part of the structure? It will be the lateral stability system of your building. So there are various stability systems. One is shear wall system, then there is moment frame system. So whatever is the frame system of your building that will provide the that will take the maximum wind load, basically. Yeah, next.
What is the procedure for placing column and slope area? Is it necessary to cut or fill the area? Can't we provide the column and then level according to the height?
I don't really understand the question, but it's also very difficult to answer on such a generalized level of how to place column and slope area. The straightforward approach is to either cut, level the area, and then provide your column with the foundation, or you fill up, level the area, and provide it with a foundation and column. But I cannot answer much more without actually seeing more details.
Okay,
Then
there's one more question on columns. Does the thumb rules for column marking for irregular shaped buildings vary?
the only issue with irregular shape buildings is certain shapes create torsion in your building. If you go for uh, you if you go for certain height of a building, you should make sure there is no torsion mode in the building. That is, your building should not twist in torsion. But this is created by certain way of placing your columns or your walls around the building. So that is the only consideration you will have to make for irregular shaped buildings. But other than that, the thumb rules are mostly applicable for all sort of buildings.
So next we are moving on to a lot of career related questions.
Mm-hmm.
We will start with this one. I have recently completed my btech. What now? Where can I start? I have only theoretical knowledge. Where can I apply?
Okay. I'll try to answer this in stages of how we can do that, or what I did during after I finished my BTech. And I am only a bachelor student. I don't have a master's, at least as of now. So I can tell what I did. So the first thing is, anybody who's trying to employ you will know that you only have theoretical knowledge because you are just finished your studies. So you don't have to feel bad about it or worry about it. That is the fact. The first thing you can do is, during your college, maybe you had a chance or maybe you didn't, you can try to get some internships in any companies in the field that you want to do. The thing with civil engineering, you have a lot of options. You have structural engineering, you have geotech, you have construction itself, you have oil and gas, offshore structures, bridge engineers. There's a lot of options. So you can try to get as become an intern, even if it is not paid. Some companies allow internship without. Most of the companies give stipend also, or if you are really interested, you can even try to work as an intern just to gain experience. So that is one way of getting some sort of practical knowledge, and that will help you in your job search. The first thing that you need to do is try to see what the market is requiring. So most of the companies require some sort of softwares, like I said, ETABS or SAFE or Stat Pro. So see if you can do some additional learning on these softwares. You can try to enhance your skills on these softwares. That is one way you can do. The second thing is, there is always abundance of knowledge around you. It is not just in your books or in your college. You can try to read online materials in the area of your interest. You can try to do some sort of project on your own, like you take examples from the internet and then you try to do your own analysis and design. If you know a software, try to do the design in the software that you know, and you prepare a report or a portfolio of all the works that you've done. Now, these are not essentially works you have done for a company, but it just shows that you have the interest to do something out of your college work only. So you have your degree, but then you have done, for example, let's say you designed a 6-story building on your own. Now this is not a constructed building, or it's not going into construction also, but you have done it out of your own interest, and you make it like a portfolio. And when you go for an interview, or whenever you get an option to apply for an interview, you apply it with your resume, and you also send in this portfolio. So it gives an to whoever is reviewing your application, he gets an interest that, okay, this is a student who has gone out of the way to do something to improve his knowledge. So to this, you can add your certifications from some other training centers or whatever it is, which gives these courses on various softwares. So that is one way of doing it. And you also, not only your technical skill, you should also improve your communication skill. See, one thing very important for engineers is how you communicate to your architects, how you communicate to your seniors or to your clients. So you also make sure that you are improving your communication skills. So this also you can do through various ways of doing it. You can even do it by yourself. So all these things, it is important that you do this, but at the same time, it is also important that you make a record of what you're doing. So you keep track of all the efforts that you're putting in. And when you get an opportunity, you express all these things that you've done. So you make a portfolio, you show the portfolio, then you stand out from other people who have not done it. So, in fact, you attending this webinar itself is a good start. So you are trying to do something additional to your everyday work to try and to learn new things. So this is the process that you have to do. So you finish your btech, then you do additional skill development in terms of technical as well as communication. Make sure you record all your activities, even if it's a small activity of designing a beam. You make a proper record of it, you put it in a file, and you take it along with you when you go for an interview. And then you show this to your interviewer that this is what I've done. And you also talk to some of your some seniors. There's various ways you can get in connection with people who are in the profession already. You can go through LinkedIn. There are a lot of forums like SEFI is there, which is Structural Engineers Forum of India. So these are all places where you can communicate with people who are already in the field. And communication means, I don't mean you go and ask a person, can I get a job in your firm? That is not the sort of communication I'm saying. It, you need to genuinely try to learn things from a senior who's in the field. And when you do this, you get contacts with various people, and through those contacts there are chances that you get job opportunities, or you get chances of being referred to some places. So you grow your network, but grow it in a professional way. So all these things put together, I know it's a difficult market, but somewhere something will click if you keep doing this right thing. I think that is enough for this question. Maybe we'll have more questions similarly.
Which companies would you recommend for a structural engineer to have a good career and salary?
There are a lot of companies. I cannot, or I don't want to name any few companies, so it becomes biased in that way. But you can always go online, go on LinkedIn or go on Google, try to type out what are the main structural engineering companies in your place or in India or abroad, anywhere, and then you'll get this list. Now, then, once we get this list, it may not be a very good list. You go to the company website, you try to understand what they're doing. If it is in the same interest as yours, then you have a good company. And there are also places which are not active online. So you know people who are working in this field. You can ask them, okay, can you suggest me some companies? And then you will also get a list like that. Basically, you have to make your own list of companies.
Is it a good idea to do MS in structural engineering? Can I get a job in countries like Australia, UK, Canada, etc. after my bachelor's in civil?
So it is always a good idea to learn more and to have more degrees if you can afford it, and if you have the time to do that. Definitely you can do an MS. It's always an added advantage. But the only thing is, when you move on to MS in structural engineering, you are reducing your scope of work also to structural engineering. So make sure that you are really interested in structural engineering before you choose to do the MS. That is the only thing I would recommend. In terms of getting a job in the countries that are stated, uh, to be frank, with just a bachelor's degree from India, it may be tough to get a job there. Any of these countries that I mentioned here will prefer to have a, degree from their country or their universities. So if you are planning to do an MS and you want to work in one of these countries, you choose to do MS in one of these countries. So you finish it there, and then it is easier to get a job there. Okay, next one.
How much work experience would I need to start working abroad? What are the opportunities for structural engineering in UK?
Work, yeah, it's there is no set benchmark for what is the work experience required to work abroad. If you are lucky, you can get a job without any experience in India also. You can directly go as and join as a graduate engineer in one of the companies in UK or anywhere in the world. But it depends on how much effort you are putting into doing that. There is no set benchmark on required work experience. You will have to just look for what are the job opportunities allowed or available, and then that will give you an idea of what is the experience generally the companies are looking for. And some of these countries, they may not really accept experience from other countries uh, in the equal terms to the experience in their companies. For example, you work in India for 5 years, but you apply to UK, they may not consider it as 5 years worth of experience for some reason. Or you work in Middle East for 5 years, you go to UK, still they may not consider it as 5 years worth of experience in UK. So there's a lot of different ways companies approach this. So I cannot say there's a required benchmark. It is only depending on the job opportunities. You will have to apply and see what they take. Opportunities for structural engineers in UK is uh, quite good. Of course, you have challenges because of COVID at this time, but generally opportunities in UK are quite good. There are a lot of top international firms working out of UK, working for projects in different countries from UK. So definitely there's a lot of opportunities there, but you will have to meet certain requirements to land a job easily in UK. You'll have to become a chartered engineer and so on and so forth. If you the best way you know all these information is, if you're interested in a job in a certain country, go online and search for jobs available in the country, in that particular country, and then you look at what is the job description, or you look at what are the requirements to apply for this job, and then you get an idea of what they are looking for, and then you try to meet each of these requirements. So that is the best way you will know what is actually required. But in terms of opportunities, it's good. Next one.
Why is there always a necessity for experienced personnel to only get job opportunities related to structural engineering? How can I sell myself in the mass market and convince that I will be suitable when experience becomes the big entry barrier?
It's it's a nice question. It I would say it is partly a misconception that there is always a necessity for only experienced personnel. I know majority of the companies require experienced people to do any job, not only just structural engineering. Maybe this particular person is looking for structural engineering jobs, and so he gets that sort of impression. But it's the case with any field generally. So it's the basic idea is the company needs somebody to start immediately on a project or immediately on work. Then if it's an experienced person, then it's easier for him to start. The company doesn't have to spend money to train the person to do the job. So that is the basic idea. But there are also a lot of opportunities for freshers or for people with lesser experience. Of course, you may have to compromise on salary, or you may not get what you want in terms of salary, or you have to work longer hours in some time. There is always this additional effort you have to put when you're starting your career. So if you're ready to do that, there are definitely opportunities out there for you, even if the even if you see, it seems like there's not much jobs around. If you keep looking, I'm sure there will be jobs that come up to people who are not too much experienced, also with lesser experience. In terms of how you can sell yourself in the market, is again, it's a very good question. Like I said, in terms of experience, if you're not able to get the experience in your current job, you can always spend time away from job trying to do what you think is required. For example, to be a structural engineer, you can practice or you can design a building on your own. You don't have to wait for a project to do this. You prepare the design of a building, you prepare the models in any software that you know, and you record all of these things. You make proper design reports of these things, and then you make a portfolio which says you have designed this building. Now you can explain to the interviewer that, okay, I didn't get a chance in my current job to do this, but I have done this out of my own interest. How they take it is up to them, but you have put in your effort. So that is, it's the many people who apply for job, they only send their resume or they only take their resume when they go for a job. A very good way of selling yourself is to have a portfolio of work, which is basically a record of what all you have done in your career. And also out of your career, like you do some additional courses, you can record that also. So this is what I said some time back. It is the same thing. You prepare a portfolio, and then you prepare your communication skills, then it is easier for you to convince anybody. Next one.
What are the opportunities in civil engineering for female candidates? What should we do after completion of btech in search of job?
This is again, I would say, we don't need to stereotype that there is a female candidate or a male candidate. I know it is tough, or it is the general conception that it is tough for female engineers to survive in the civil field. But I have worked with a lot of female engineers, and I have even had some good mentors who are female engineers. And I have learned a lot under them. So there is really no barrier in being a female and being a civil engineer. So there is nothing different that you have to do. It is the same thing that any student after bachelor's will do. But in terms of, yeah, if you think you cannot go to the site, you always have other fields of work like design. You have quantities estimation. You have a lot of field in design itself. You have building design, road design, or you have bridge design. So there's a lot of design work. There is a project management work. There is also estimation quantity work. There is tender departments. There's procurement departments. So there are a lot of opportunities for female engineers as well. And in fact, the industry is also ready to encourage a lot of female engineers, civil engineers, to come up and do and work in the field. So there is nothing different. You still need to do the same things that I explained in the previous question. And that's it. You keep trying. I'm sure you will also find a good opportunity.
What is the demand for civil engineer in the design field?
Like I said, the design field includes design of buildings, design of bridges, road design is there, highway design is there, and then you have offshore, you have oil and gas design field. There's a lot of opportunities. I would say it is equal in terms of site engineers and design field. There is a lot of opportunities, definitely. And also in terms of design, you have the additional opportunity to work in companies which are outsourced from other countries. Like there will be design firms in UK who have their outsource office in India working for projects in UK. So in the design field, you have this additional opportunities to work remotely for projects in other countries. And there are a lot of top MNC companies who are doing this now. So they have offices in India which are basically working for projects in Middle East or in UK or US. So there's a lot of opportunities there.
To become a structural engineer is MTech mandatory. I think you have already answered the question.
Yes, so I'm an engineer without MTech. So it's not mandatory, but it is an added advantage definitely. At some stage in your career, it helps you if you have a master's. Yes.
I'm a structural engineer. I want to freelance structural engineering or own my own business. What should I do?
This is more of a question for a MBA student than for a structural engineer, I think, because I cannot tell you how to build a business. I can tell you to be a good structural engineer, which is you should know all the basic concepts of structural engineering, and you should be confident to do a project on your own without any person reviewing it in most cases. That is most critical thing. You need to be absolutely sure that what you are engineering as a building is safe for people to stay, because you are the basic thing of structural engineers or any civil engineer is we are providing something for people to stay in, and we should make sure that it is safe for people to stay. So as a structural engineer, I can only tell you that you should be confident in the engineering part, and I cannot tell you how to develop your business.
Okay. So, can you tell us some job opportunities in Revit architecture?
Revit, I can tell you in Revit itself. So Revit is basically BIM, which is building information modeling. This is one of the hot topics in the civil engineering or in the construction industry itself. So to give a brief intro, BIM, building information modeling, is basically you build 3D models. Earlier it was AutoCAD doing 2D models. Now it is all 3D models that we do of any structure that we are about to build. And then there is architecture doing their own model, then there are structures doing their model, and mechanical engineers doing their model. And all these models are put together to make sure that all of them fall in place, to make sure that there is no clashes between any of these different models. For example, you don't want to put a column in front of a door, or you don't want to run an AC duct in the middle of your beam. So all these things are checked using BIM. That is what Revit is, one software which is part of building information modeling. So you have opportunities in Revit architecture, which is basically you build the model for an architect. It will include your basic architectural requirements like floor finishes, windows, doors, your interior work, all those things. So that is Revit architecture. Similarly, there's Revit structure, which is basically you prepare all the column layouts, your beam layouts, your reinforcements, everything in Revit. In terms of job opportunities, there's going to be a lot of job opportunities in Revit, because there's all the construction activities or the design activities are now being moved into Revit. So mostly all the projects are being done in Revit now. And also there are a lot of companies which are working for projects abroad from India for Revit work alone. So there's a lot of opportunities there, and you can find online which are the companies using Revit or working for Revit, and then you can apply there. But I'm sure you will have good opportunities there. Next one.
So, I'm a structural engineer working as a CAD trainer with 2 years of hands on experience in software such as AutoCAD, Revit, StatPro, ETABS, and Primavera. I have developed many analysis designs and modeling projects in and around Hyderabad. And also, I have a good rapport with educational institutions and universities around Hyderabad as I take up FTP's guest lectures and workshops for students and faculties on above softwares. I am looking forward to change my job location to the Middle East. So please guide me on how to approach and get a good job in UAE or Kuwait.
Okay. Uh, in terms of getting a job in UAE is generally, uh, I'm just thinking which is the best way to answer this question. He has a good experience, definitely 2 years of experience in all these softwares is good. But with the current situation, the market is quite tough in UAE or in Kuwait or anywhere. There's a lot of issues or challenges going into the job market here. So it may not be the best time to relocate, I would suggest, but you can always keep trying. And the best way to try is you try to develop more contacts in the region that you are trying to apply to, because then you have chances of getting references to various companies through your contacts. So one way is to develop your contacts professionally through LinkedIn or through various forums that I mentioned earlier, and then keep a track, or I would always suggest to anybody who's looking for a job, keep a list of companies as an Excel file or anything. So you have the company name, you have their website address, and your job opportunities page, all those things, and keep checking these every day. Because you never know when an opportunity is posted in their website or online or anywhere. So make sure as a ritual to check these companies in your list every day to see if there is any job opportunity, because some of these job opportunities, when they come up on the website, you have hundreds of people applying within a matter of hours. So it is really a very competitive market. So make sure you have a list of the companies that you are targeting to work for, or in which you are interested, and keep checking these regularly for any openings. The moment you see an opening, you upload your resume, and try to get in contact with the person who's posting it if there is an opportunity. And keep doing this. Also develop your contacts. The other way is you can try to visit here. If you have anybody who's staying in this region, you can come here and start looking for jobs also. But the market currently may not be the best time to do it. Anyway, but if it's better you develop contacts and talk to somebody who's within the region, they can guide you better. Yeah, next one.
After diploma in civil, what is a suitable job or further study?
My straightforward suggestion is to go for at least a bachelor's, because currently diploma in civil alone may not give a very good job opportunity. It is better to do a bachelor's at least in civil engineering. But if not, you can also do additional courses in maybe Revit or in any of the softwares, and then you can go into the field of Revit modeling also, or you can try to apply for certain site engineering positions, because I don't think design engineering options would be available, or at least not many opportunities will be available with just a diploma. So Revit could be a good option. If it's possible, it's better to do at least a bachelor's.
I am a 2020 pass out graduate and work as a design engineer in the field of PLVA, that is steel structure designing. What is my future growth? Should I stick to it or should I look for jobs in building designing and other things? What should be good for me as a fresher? Is steel structure designing Does steel structure designing has growth?
See, any field of work has its own strength, I would say, and has its own requirements. So this PLVA, I assume, is something into your pole design, and which is, I think, a very specialized field of work. And then if you're a master in your specialized field of work, you'll always have job opportunities. So it is any field of engineering will definitely have its own growth in terms of uh, job opportunities. But if you want to move on to a better jobs, definitely you can start looking into it. You're already into a steel structure designing, which means you know the basics of steel, and you are going to apply the same thing for a building design. So that is also a good background that you have. And steel design will definitely be there for a long time. The industrial structures are all steel. There are many structures which are better to be built in steel compared to concrete. I know in India it's mostly concrete works, but steel has its own advantages, and it is preferred over concrete in certain types of structures. So definitely steel is good. If you don't know Stat Pro, I would suggest you learn Stat Pro. That will add to your capability of steel structural designing, and do a couple of projects in buildings to know how it is done. And then you will have a good portfolio to present and move on to building design if we get a chance.
I think that's the last question. What is the scope of AI in structural engineering?
Nice question to close off. AI, artificial intelligence, is something that the construction industry has not really taken into board like some of the other engineering fields. Construction industry is very slow in adopting AI, but there is a huge scope of AI in the future. Like many of you will know, there are 3D printed buildings which are already done in some of the countries. So the industry is trying to see if we can bring 3D printing on a large scale, which, like I said earlier, for your repeated elements or repeated buildings, it is much faster to use 3D printing, which is a form of AI, and also to use AI in specific fields of construction, like you have a block work laying, for example. It is a repetitive work. So once you feed into the system how to do block work laying, it may be doing continuously for 24 hours. So it saves a lot of time, and it increases the speed of construction. So that is in terms of construction. There is a lot of opportunities in terms of design. Like I said about BIM and clash detection, and making sure all the elements are coordinated. There again, AI will be used to determine that all the clashes are resolved, and also to give, even in terms of software programs like etabs, maybe in the future you can have AI telling you, okay, this is a better or more efficient design. So there are opportunities in of using AI in softwares also. And in terms of project management, you can use AI to go through a lot of data and then finding out where the delay is happening, or where we can make the process faster to increase the speed of construction. So there's a lot of scope. It is slow at the moment, and it may not happen in the near future also, but definitely there's a lot of scope. And it's a good thing to study more and have a knowledge about also. Yeah, that was the last one, right?
We have a few questions in the chat box. We'll just
Okay.
go over them shortly. So,
Yes.
how is the land chosen by an engineer for high-rise buildings?
Sorry, can you repeat it?
How is the land chosen by an engineer for high-rise buildings?
Land, you mean LAND, land?
Yes, land.
Okay,
LAND.
see, firstly, a structural engineer has very little role in deciding. I will just briefly tell the whole process of building a, or deciding on building a high-rise building. So there is a client, generally a rich person with money, who probably already owns a piece of land. He goes and meets an architect, or he appoints an architect. He talks to them, he tells them his requirements basically. So the architect then decides, okay, this piece of land, this requirement, how many floors are required. And then you get an idea if it's going to be high rise or a short rise or whatever it is. Then they appoint a structural engineer, a geotechnical engineer. We do our feasibility studies, and then we advise the client, okay, you want a G plus 50 building. This place cannot accommodate a G plus 50. It can accommodate only G plus 40. But there will be very few instances that the engineer tells it cannot be done. Most of the places we have the technology now to achieve what is required. So we just tell what will be the requirements to construct the building that is required. If you need a high rise building, you will need this sort of piling foundation to be done. You will need this sort of column sizes or wall sizes. So we give some approximate sizes. Then the client goes to a costing engineer or estimation engineer. They do a calculation of all these sizes, and then they come up with a cost for the project. Once you have a cost for the project, which will be approximate in the initial stage, but once you have the cost, then the client makes the decision, okay, I can do this or I cannot do this. Now, the role the geotechnical engineer plays here is, as a structural engineer, I will tell him, this is the load I want to transfer into the ground. So he does his calculations. He tells, okay, with the current soil, you can do this or you cannot do this. If we cannot do it, there are ways to improve the soil. There are certain ways like dynamic compaction or vibro replacement. Okay, so that's what the geotechnical engineer says. We can take this load. If not, what is the ways to improve the soil? So we always find engineering solutions to what the client requires. Ultimately, it is the client who decides if he has the money and if he can get the profit out of constructing a building. So structural engineers will only give solutions to how we can achieve what the client wants. So we don't, there is very minimal role in us choosing a land or not choosing a land. It's basically us telling how we can achieve what the client requires. There are other factors which decide on the final outcome of the project.
Okay, thank you so much. There's a question from Amrita. Can you discuss some thumb rule checks for cross-checking designs?
I don't think this is the platform to do that. That will be a separate webinar in itself if you had to do thumb rule checks. But you can find a lot of books which do that. Or I mean, if required, I can provide. If they contact me later, I can provide some references.
Okay, sure. Thank you so much. There is a small question from Salim. MS or MTech? Which one do you think is better for structural engineering?
Anything structural engineering is good. See, at the end of the day, it is how much interest you show in learning something. It doesn't matter if you do an MTech or MS or a BTech or BE. All these things are, yeah, I know it is required in some conditions, but in terms of knowledge, it is always what you make, how best you make out of what you're learning. So there is no difference if you ask me. You just learn anything structural engineering, and then you gain your knowledge from it. That's all.